Math Morning, Mr. Durkis, back at it again. Today we'll be solving linear systems using substitution!
Alright, so we're going to solve these systems by substitution. What we did in the last lesson, that was graphing. This is going to be more algebraic. So this is called substitution. Here are the steps. Step number 1. Solve one of the equations for one of its variables. When possible, solve for a variable that has a coefficient of 1. So coefficient, that is the number in front of the variable. Step number 2. Substitute the expression from step 1 into the other equation and solve for the other variable. Step 3. Substitute the value from step 2 into either original equation and solve for the remaining variable. Step 4. Write your solution as a coordinate point or a pair of values. Alright, that might seem a little bit foggy, so I'm going to do an example with you and hopefully it'll make more sense. Alright, so this system of equations, we have two equations. Here is the first one, there is the second one. Let's follow the steps. So step 1, solve one of the equations for one of its variables. So you can choose either equation you want and you just have to solve for a variable. And when I say solve for a variable, it means x equals something or y equals something. If I look at this one right here, it's already x equals -6 plus 2y. So I don't have to do anything. If it's already solved for one variable, that's all you got to do. So I'm just going to write x equals -6 plus 2y. That's it. So I solved one of these for a variable. The variable I solved for was x. Alright, I'm going to do some color coding right here. Hopefully this will help. So this x, right, I'll make that blue. And everything that's equal to this x, I'm going to make that blue also because it's all the same. So this -6 plus 2y, that equals x, right? X equals -6 plus 2y. It's the same thing. It's like saying this is $10 and you have 2 5s. It's just a different way of expressing it. Also, in the first equation, this x is also blue, right? It's the same thing. This x is the same as that, and it's the same as -6 plus 2y. So with step 2, it says substitute the expression from step 1 into the other equation. Alright, so my original equation, let me change my pen color to make this work. So I have 4x, I'll use blue for x again, plus, let me go back to the red, plus 6y equals 4. So that's the one on the top. Substitute the expression from step 1 into the other equation. So I've got this right here. Instead of this x, I'm going to put in -6 plus 2y. I'm going to change it up. I'm going to switch it around. And I'm allowed to do that because they're equal. So when I rewrite this equation, I'll do it with my red again, it's going to be 4, and then I put parentheses. Instead of x, that's when I write the expression. So I'm going to write this, -6 plus 2y. Alright, there it is. That's step 2. I just substituted for it. I need to finish the equation though. So I write plus 6y equals 4. So it can be a little tricky, but all I did, instead of using this x, I wrote what x is equal to, which is -6 plus 2y. Now I need to solve, right? This part right here says and solve. So let me solve this equation. I'm going to use the distributive property. I'm going to write this again just so it's clear. We got -4 minus 6 plus 2y plus 6y equals 4. You'll notice now I don't have any more x's. There's no x's in here, and that's the goal. So that means I can get a number that equals y. So if I do 4 times 6, that's 24, and it was -6, so it's -24. 4 times 2y, it will be plus 8y, and then I have plus 6y equals 4. Alright, Now I'll combine the like terms. 8y and 6y, that's going to be 14y. And I have negative 24 plus 14y equals 4. Now I want to get y by itself, so I'll do plus 28 plus 28. Oh, not 28, 24. Mr. Durgus, come on. Plus 24 plus 24. That cancels, and I have 14y equals 28. Now I want to solve for this y, so I divide by 14. Divide by 14. That cancels. Y equals 20 divided by 14, and that is 2. So I solved for y. This whole step at the beginning, I substituted for x, and then I solved for y. Alright, that can be a lot, but that's what we're doing. Now we're on to step 3. It says substitute the value from step 2, that's right there, into either of the original equations and solve for the last unknown variable. So I can take y equals 2, and I can plug it into either of these equations, and I just solve for x. I can do whichever one I think looks easier, and I should get the same thing. So let me put it into the first one. So we have 4x plus 6y equals 4. Instead of y, I'm going to put in 2. So 4x plus 6 times 2 equals 4. Then I have 4x plus 12 equals 4. Now I want to get x by itself, so I'll do minus 12 minus 12. That cancels. 4x equals negative 8. And then I'll divide by 4, divide by 4. That cancels, and x equals negative 2. There we go. In the last step, it says write your solution as a coordinate point or pair of values. So coordinate point, that's when you have x then y, right? So I'm just going to fill that in for what I know. The x is negative 2, and the y is what we found in the first one, is 2. So my answer is negative 2, comma 2. Bam! Done. This is the answer right there. Negative 2, 2. If I put it into both of these equations and I test it, they should both be true. Okay? You can test it if you want, just to verify your answer is right. And now I'm just going to quickly review the whole process just to refresh it, let this marinate in your head for a little bit while we go back. Alright. So we had these two linear equations. We solved for one of the variables in one of the equations. We noticed this one already had an x by itself, so we said, okay, it's solved. Step 2, substitute the expression from step 1 into the other equation and solve. So we took the first equation right here, 4x plus 6y equals 4, and we substituted what x equals. Bam, right there. Then we went through, we solved it, and we said, okay, y equals 2. Now that y equals 2, we put that in to one of the equations. It could be either one. So we did the first one, and when we saw y, we put in a 2, and we solved it for x, and we got x equals negative 2. And that's how we got negative 2, comma 2. You might be thinking, man, that's kind of tough. And I agree, it can be challenging. That's why I'm going to hook you up with a pep talk right now.
Do it! Just do it! Don't let your dreams be dreams. Yesterday, you said tomorrow, so just do it! Make your dreams come true! Just do it! Some people dream of success while you're gonna wake up and work hard at it. Nothing is impossible. You should get to the point where anyone else would quit, and you're not gonna stop there. No, what are you waiting for? Do it! Just do it! Yes, you can! Just do it! If you're tired of starting over, stop giving up.
All right, I'm ready to go. So let's do some examples. You've got this one right here. Step 1 was solve one of the equations for one of the variables. If we look at the first one, it's already done for us. Y equals negative 7 minus 3x. So we already solved y equals negative 7 minus 3x. It's already done. So what it says after that is to plug the value of this y, which is negative 7 minus 3x, into this y. We're substituting. So I'll rewrite it. Negative 2x plus 4. Instead of y, I'm going to write negative 7 minus 3x. Negative 7 minus 3x. And this, because it's this equation, equals 0. Now I want to solve for x. Alright, if I look, there are no more y's, so I can solve for x. So I'll write, let's see here, negative 2x. Now this part right here I need to distribute. Plus 4 times negative 7, that's going to be negative 28. Alright, just distributed that. Now I'll do it over here. Plus 4 times negative 3x, that'll be negative 12x. And that equals 0. Now I want to combine my like terms. I've got a negative 2x there and a negative 12x right there. So that becomes negative 14x. And then I have minus 28 equals 0. Now I'll do a plus 28 on both sides. That cancels, and I have negative 14x equals 28. And then I divide by negative 14. Divide by negative 14. That cancels, and x equals negative 2. Bam, boom, boom. So that's the answer for step 2. And now I need to take this and plug it back in to either of these equations. I'm going to choose the first one. So the first equation was y equals negative 7 minus 3x. Y equals negative 7 minus 3x. So instead of x, I'm going to use negative 2. So y equals negative 7 minus 3 times negative 2. Y equals negative 7, negative 3 times negative 2 is a plus 6, and that equals negative 1. So y equals negative 1, x equals negative 2. Here is your answer. Let's see. X, negative 2, y, negative 1. Bam. There's your answer. Alright, let's do the second one. You might look at this one and say, hey, it doesn't look like the other ones. That's okay. We still do the same steps. The first step was solve one of the equations for one of the variables. And look, this is x equals something, and this is x equals something. So it's already done, right? We have one variable by itself. So we can choose either one. I'm going to choose the top one just for fun. So x equals 2y plus 5. So I'm going to take this, the 2y plus 5, and plug it in for the y value over here. Oh, I mean not the y value, for the x value, because it equals x. So instead of this x, I'm going to write 2y plus 5. So 2y plus 5 equals 10 minus 3y. Alright, now we've got some steps to do to solve this for y. I'm going to use the old line in the middle to help out. So I'll take this minus 3y, I'll do the opposite, a plus 3y. That cancels. I'll do a plus 3y over here, and I get 5y plus 5 equals 10. Now I'll do a minus 5 minus 5. Those cancel, and I have 5y equals 5. And now I divide by 5. Divide by 5, that cancels. Draw my line. Y equals 1. Bam. Now I'm going to take this and plug it into one of the equations. So, which one? I could do either one. I'll plug it into the first one. So we have x equals 2y plus 5. X equals, instead of y, I'm going to put 1. 2 times 1 plus 5. X equals, 2 times 1 is just 2. 2 plus 5 is 7. So we have y equals 1, x is 7. Remember, when you write a point, it's x, y. So that means 7, comma, 1. All right, let's do 2 more. So over here, step number 1, solve one of these for a variable. Whoa, look what we got here. Y is already by itself, so it's already solved. So that means I'm going to take this x minus 1 and plug it in for this y. And this is why parentheses are so important. So 2x minus, instead of y, I use parentheses. X minus 1 equals 5. So the reason parentheses are important because is a negative, right? And when you distribute, you need to distribute to both of the terms. So when I solve this for x, we're going to have 2x minus x times x is minus x. Minus 1 times negative 1 is a plus 1, and that equals 5. Now I combine like terms, 2x minus x, well that's just x. So I have x plus 1 equals 5. And now I will do a minus 1, x equals 4. Bam. So that's the answer to step number 2, right? Solve the first one. I can plug it into either of these equations. I'll plug it into the first one. So x is 4, so that's x minus 1 equals y. So 4 minus 1 equals y. 4 minus 1, that's 3 equals y. So x is 4, y is 3. Our point is x, y. So 4, 3, 4, 3. Bam. All right, question number 5. So step number 1, solve one of these for one of the variables. Well, all the other examples, they were already solved for you. This one, it says x minus y equals 3. X and y is not by itself. And the same down here, x and y not by itself. So I'm going to use the first one. I think that one's better. I think it's easier. So x minus y equals 3. I can get x by itself, or I can get y by itself. I think it's easier to get x by itself in this one. Why? Because if I just do a plus y over here and a plus y over there, that cancels, and I have x equals 3 plus y. Alright, so now I solved it. X is by itself. So now I want to take this x and plug it in for this x right there in that equation. So that was the first thing we did. Now let's plug it in. 2x minus y equals 5. Instead of this x, I'm going to put in this stuff right here. Alright, this stuff right there. So 2, instead of x, I'm going to put in 3 plus y. 3 plus y. And then minus y equals 5. Alright, now I need to solve for y, so I'll distribute. 2 times 3 is 6. 2 times y is 2y. This is not part of this distribution, so I just write minus y equals 5. And now I combine my like terms. 2y minus y is just y. So 6 plus y equals 5. And then to get y by itself, I'll do minus 6. Minus 6, that cancels. Y equals 5 minus 6 is negative 1. So now, since y is negative 1, I can plug it into either of these equations to get my other one. I like this one again. I think that one looks a little easier. X minus y equals 3. So we have x minus y equals 3. Y is negative 1, so x minus, instead of y, negative 1 equals 3. This becomes plus, so x plus 1 equals 3. And then I'll do a minus 1 to get rid of it. So that means x, that cancels, equals 2. So y is negative 1, x is 2. Again, x, y, so 2, negative 1 is the answer. Bam. Now, I know this video, it was a lot. Your brain might have exploded, and that's okay. You just got to put it back in your head. And if this doesn't make sense quite yet, you can just rewatch this video, try again, ask me for help. But really try this one. I know it's going to be a challenge, but you can do it. You got this. So good luck with the packet. Good luck on the mastery check. Darkus out.